All right, we've got a few more good calculator problems to take a look at. Number 85. A particle moves along the x-axis. So what do we say? We say we've got someone walking, and we've got their position function as given by x of t equals cosine square root of t. What is the velocity of the particle at the first distance the particle is at the origin? So let's ignore all that, and let's read the problem again. The person is moving. The person is walking. Okay, they're walking in a straight line. So that their position is given by this function. So where are they at t equals 0? Well, we've known since we've been graphing that if I put a 0 in there, the cosine of 0 is 1. So the person starts at position 1. Then what are they going to do from there? We know that after 0, the cosine graph starts to come back down. And sure enough, so this person is actually starting at 1 and walking back toward home. Home would be position 0. So when are they at home? When are they at position 0? And what is their velocity? So I think a good idea would be to get this graph in the first time that it is equal to 0. So we can calculate that on our calculator. And that is x equals 2.4674. We really could have said, when is the square root of t equal to pi over 2, and squared that. I bet you that was pi squared over 4. But then we put this number in. Second, calculate 6. And we get somewhere around that negative 0.3. Good work. All right, if the derivative is greater than 0 for all x, and the second derivative is less than 0 for all x, which of the following could be a table of values for f? So we are increasing concave down, so we've got to look like this. So our increase is decreasing. Well, this one is not increasing the whole time. This one is not increasing the whole time. This one is increasing at a steady rate of 1 and 1, so its increase is not decreasing. This one is increasing by 1 and then increasing by 2, so its increase is not decreasing. This one is increasing by 2 and then increasing by 1. That is our only option. 87 is one of those problems where we really want this one to be on our test, because we can just put it into our calculator. 3 minus 2x minus x squared times the sine of 2x minus 3. And for this entire test, we'll be in radian mode. And we'll take a look. Make our window somewhere from -4 to 2. And that graph looks like something like this, depending on your scale, of course, from -4 to 2. Now, I think a mistake you could make here is forgetting that you are going from -4 to 2 and leave your window from like -10 to, I don't know what it would look like out there, but you don't want to get in that trouble. So it looks like we're our extrema. Our extrema are when the first derivative equals 0. So where's the first derivative equal 0? Here, 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 and here. That's where it equals 0. But it also has to change from increasing to decreasing, or from decreasing to increasing, meaning from positive to negative or from negative to positive. And that does not happen here. but it goes from negative to positive, from positive to negative, negative to positive, positive to negative. So 1, 2, 3, and 4 would be the correct answer. Try to trick us with that negative to negative right there. All right, I've got a graph interpretation. Which of the following is true? And we've seen this problem on every single practice test we've done, or a problem just like this. If I've got the graph of the function, which of the following is true? And this is the first time I think we've seen one where they have -1, 1, and 0 for our values. So we want the derivative at these 3 points. Our derivative at -1 would be 0. Our derivative at 1 would be less than 0, so negative because it's decreasing. And our derivative at 0 would be greater than 0, increasing. So our smallest value should be f prime of 1, decreasing. Our medium should be f prime of -1, and then our biggest should be f prime of 0. Which one do we got there? I think that's this one down here. All right, last one, 2016. What is the volume of the solid generated when the region bounded by the graph of x equals y minus 2 and the lines x equals 0, y equals 5 is revolved around the y-axis? Great last review problem to look at. We can actually look at this in 2 different ways. The first way I'm going to look at is I'm going to switch every x and y. I'm going to say y equals x minus 2 about the lines y equals 0 and x equals 5. Then it is totally a problem that makes sense to us. X minus 2, square root looks like that, from 2 to 5. Y equals 0 is right here. And here's our area, and we're going to revolve it around the x-axis because we switched everything. So we've actually just got disks. Pi r squared. So pi 2 to 5 of square root of x minus 2 squared. And I think I get 4.5 if I plug that into my calculator, which actually is an option, but that would mean I forgot to multiply by pi. 4.5 times pi, I think, is 14.137. Good work. Math it up.